Welcome to the last lesson of our first incarnation of the NUKE practice hour. My name is Helge Maus from pixeltrain. In this first chunk of lessons about NUKE, I wanted to give you all the background you need to understand NUKE better, and I hope this was good for you and you understood much more what's going on behind the curtains, so that in the next practice hour we can dive into more practical examples of everything. It is really important from my trainings experience that people understand what's going on inside of NUKE. So if you have more questions about these fundamentals, please let me know in the comments below. And if you like these tutorials, please support me by giving me a thumbs up, subscribe, and if you want, I'm really happy if I get some Patreons. So if you have $1 left, you can spend it. But now let's start here for this last lesson. Today we want to talk about linear colors, 32-bit float colors, and EXRs, and all kinds of crazy stuff. So it's again really important that you understand that for your production, and let's dive into the topic by loading here an image from my trainings data. Let's go here to teaching, and I have here a gamma chart prepared for my trainings. And in this gamma chart, I want to explain you a little bit what a gamma is and what is a linear image and what is a gamma corrected image. Let's take here the first column here. You see this nice image here with Marcy here and also this curve. And this curve is a representation of a color gradient from black to white. And the idea behind this here is that we generate an image on a mathematical device. So we generate pixel data which are mathematically generated. And for the computer, it's really good to have the gradient from black to white. And you expect then that you have a curve which looks exactly like this. So you input black, and black is the outputted thing, and you input white here, and white is outputted. So that's linear. And to see it more through a human perspective, you can see here this image. So this is the original appearance of the image. This is something I would expect to see. But there was a time when we had our first monitors with colors, and when we used the image like that on these monitors, you will run into a little problem. Surprisingly, the image doesn't look like that here, it looks like that here. And you see, it's not only darker, it's really off. And the reason for this is that these monitors were not able to show linear colors. They had a curve, if you analyze the color curves, which looked like that here. So your gradient would also look like that here. And this problem had to be solved. And we solved this problem with a so-named gamma correction. And a gamma point is the point which is half gray. So the 0.5 point here in the gradient, if you look this point up, here is 0.5, and here, this point we normally name is the gamma point. And we need a correction which takes this gamma point and moves it up and down. So this is gamma correction. And the rest of the curve here is like an elastic band. And if you have now a monitor which represents colors like this here, we need a gamma correction where we move the point up. And it's like a multiplier. If you don't want to change a value in the gamma is 1. So that's exactly why this here is named gamma 1. So you take this point and you manipulate it with a gamma 1, which means the curve is not changed at all. If you take now a gamma value which is higher than 1, for our case a gamma of 2.2 for example, you move this gamma point up and the curve looks like this here. Mathematically spoken, this here is too bright, but on a monitor which represents color like this, the image looks perfectly like this, and you were happy. And we had a long time where all our images were gamma corrected. So we gamma corrected them with 2.2 or 1.8. You can read a little bit about that, but all these images were gamma corrected. But the problem is that if you now work in a high-end software and you want to manipulate colors, a curve which is now physically written into a file which looks like this here makes many problems. A computer likes linear curves here. And so in a software like NUKE, we have to remove this wrong gamma curve to have again a linear curve. And we remove this curve by the inverted curve. So you have a gamma correction of 2.2 in the image, then you have to remove this gamma by the opposite. So I think it's around 0.454, something like that. You can, calculate it by yourself if you like, but you don't have to. That's the nice thing. And this problem only occurs at the moment if you have 8-bit or 16-bit images. Meanwhile, most of the CG renderers we do are EXR, so this is the industry standard, and industry standard means that everyone in visual effects should use it, and these EXRs are linear. So by default, they use a linear curve. But also in other areas, for example in HDRIs, we really often use linear colors. And also there are formats like, for example, 32-bit TIFFs. You can have a linear curve in it, but the problem is it is not a standard. Let's take now a look how NUKE works with that. So for this, I take my read node and I go back into my images and I load some images here. For example, this time we load this image here. I click next to mark this for loading, and I also take this product renderer next and I load it here. And also I prepared here a folder, I think, color workflow images here, where we also have some more interesting images. And here's the oil image again, but this time as a DPX. DPX is sometimes a file format which you get under your fingers. Graders still use this image format. It's a really old one, but it's still out there. And the curve of this image format is really interesting. It's a 10-bit logarithmic curve. So I take a DPX here and I mark it, and then I click load all the stuff. Okay, now we have our 3 images. And we start here with our friend the JPEG, which is a really big one. So let's bring it into a better shape. So let's use a reformat node. We've done this many times before. I want to not use a format here. You see it now takes the root format. And because we have here pixels which are not filled, which are normally black, it uses the last pixel here to fill this area. You can prevent that by clicking here black outside, but the image is wrong. So let's turn it first. Wrong direction, flop it. And then we go here instead of format to scale. And now you can scale the image. If you have a scale of 1, it's the original plate size here. And we want to scale it down to 0.5, for example. Okay, now we have a nice JPEG here. And like I've said, a JPEG normally is 8-bit. And in 8 and 16-bit, we normally have this gamma thing going on. We have now to remove the curve here. And if you make a double click now on this read node, you will see that in every read node, we have here an area where we have a color space. And this color space says at the moment it's default, and in brackets sRGB, which has a gamma of 2.2 or nearly 2.2. What does that mean, default? NUKE looks into a table and says, okay, this is an 8-bit image. I think this would be an sRGB. I also look into 16-bit images and I say it's also an sRGB, and so on. But you can switch that. So if you open this up, you have a whole bunch of different profiles, and you can tell now the system what this image is. And what we do now here, we try this now. We say, no, this is not an RGB image. This is a linear image. So if you tell this now, NUKE, you will see it says, okay, I don't change it at all. It's linear now. But look what happens in the viewer. This image looks now too bright. And if you look here, you remember that I said that every of these 8-bit images is saved like this here. And you see it looks too bright. And that's exactly what you now see here. So if you say don't make a change here, keep it as linear, you see it's too bright. So that's the reminder for you what this thing does. Let's go back to the default sRGB here. And let's search where these color curves are. And you find them in the project settings. So if you press the S key here over the node graph, and you go then to the next tab here, color, you see these are the settings for the NUKE color management. And I use the default at the moment. You see you can switch it here if you like. And in this profile here, you now see that my monitor is sRGB. So this is true. 8-bit images are handled as sRGB, 16-bit images are handled as sRGB. Then log files, DPX as a log file, is handled as Cineon, and all other float files are handled linear, so EXRs and things like that. And if you now want to see the curves, you remember we need now the opposite curve of that, something which looks like this here. You will see if you go here to sRGB, yeah, there it is. So this is the curve which you use to remove the gamma inside of the read node. And you can look here around and also add your own curves if you are able to do that. Let's take a look here to the Cineon, because I think it's important that you have seen it. You see it's a logarithmic curve. It's really, really fast here. And if you take a look here to a DPX here, okay, this is now the DPX representation. Let's open here the read node really fast and look that here in linear. You see this is a typical image which you see if you have a logarithmic image. The darks are still there, but then everything is washed out. So this is a good reminder for you. Oh, this is a logarithmic plate. And then I can search here for the right logarithmic profile. Yeah, in our case, it's Cineon here. And if you now compare this with the EXR, you see in the EXR it's 32-bit. It directly sees, okay, it's 32-bit linear, so no change at all. Let's dive a little bit deeper into this idea to make this more clear. I go back here to my JPEG, and this time I tell here my read node that I don't want to see any changes in the image. So I go back to linear, and now you see you have an image which is too bright. What if you want to do a color conversion or a color space conversion by yourself? For this, we have a node under, I think, under the color nodes here. So here's the color space, and we use this node here. And if you now want to change color spaces, what you can do here is you have here the in, which is linear in our case, and then we have a out, and there you can say, I want to convert this. And this image here is sRGB, so I go here to in and say this is an sRGB, and you see 2.2 as a gamma, and we output linear, and now you see this is the color conversion, which you have done now by yourself. Cool. So this is also possible. But keep in mind that now all operations you do in NUKE are not correct anymore, because NUKE expects every image data in the stream linear. And so if you now do something here with the colors or so, it will look weird. There are cases when we want to change the color space for an operation, but normally we want to have linear colors. Another thing which is really important is that you understand what your viewer here is doing. So let's remove the color space, go back here to sRGB. And if you remember now here my chart, I said that our monitors normally represent an image which is linear here, like this here. So why is this image here now so bright? The reason for this is that NUKE has a really special viewer. It uses a LUT inside of the viewer. If you really want to see the original data which is there, you have to remove the LUT. And you see there's a little drop down here in the viewer, which is named the ViewerProcess. And here you see that we use at the moment for my monitor an sRGB LUT. If we switch this down to none, you see the original data. So these are the backbones of this color process. So what you normally do is we work linear here, and to see what's going on, you can tell here the viewer which kind of monitor you use. You can use here your profiles, and you can also build your own input process if you like, but in our case sRGB is okay for now. And every read node here has to be configured like that it converts the image correctly into the linear world. And don't expect that the ending of a file is always representing the correct gamma. Most of the cases it's okay. JPEGs normally use a gamma of 2.2, so sRGB is absolutely okay here. Logarithmic files, you see, you can change that if you like, if you know what you're doing, and sometimes it's really about knowing how the plate should look. And in production, if we render, meanwhile, we use most of the times EXR, and EXR uses a linear color space if you do it correctly, and then everything is fine to this point. Let's talk now about the next color topic inside of NUKE, which is the color depth. If you come from applications, and for this I use now Affinity Photo, but you also can do that in Photoshop, in GIMP, or wherever you want to work with. I opened the same JPEG, and you maybe have heard that this here is an 8-bit image. And if you go here to document, you know that you can change the depth of this image. And what I want to do is now, I want to show you what that means. If you have an 8-bit image and you look here into the channels, you see you have a red, green, and a blue channel. And every of these channels here, let's take one of them, for example, the red channel here, is a channel which has white colors and black colors and all the gradients between. And black is 0, white is 1, and you have in a normal 8-bit image, what this here is, 256 steps. So that's the whole idea. And if you have a 16-bit image, you have more depth inside of that, but you are still clamping, so you only have a value range which you can use. And this brings problems. So if you have 8 or 16-bit images, you clamp. Let's take that to a test. I take here now in my corrections here, for example, an exposure layer here. And in the exposure layer, I say, okay, I want to exposure this image up by, for example, 1. And now you see we have brighter areas here. And now we can use a color picker here. And if we now pick color here, you see that all these colors here are 255. So now we are at the maximum what a channel is able to represent, 255 for an 8-bit image. And if we now want to remove this, for example, by exposure it down again, so let's go here and say this time -1, you will see that the image is now back in a range which looks really like the original. But if we are now measuring these values here, you will see that every value here is on 186. And we have no details left at all, which were there before. You see, we had many details here. So through the problem that 8 and 16-bit channels are clamping, they have hard limits, you destroy image data while you are working with that. And this is something we don't want to have in visual effects and high-end compositing. And so NUKE uses a different approach for that. So let's take our NUKE file again. Here we are. And if you now hover with your mouse over an image, you remember that we have here these values going on, and you see these values are float values. And NUKE works with 32-bit float values, which means black is still 0, white is 1, and then you have a whole bunch of decimals behind the comma. And everything you do is moving these values up and down. And let's do now the same thing here with the same JPEG. So let's take this JPEG here, and we go here to the colors and take an exposure node here. Yeah, we can do the same here. Here we are. And if we look here, we go here to these red, green, and blue, and they are used as a gang. So if I move that here, all three will work at the same time, and I bring it a little bit up here, for example, let's say around 20% or so. Okay. Now we have really bright colors here, and if we now hover over this tablecloth, you see we have values which are over 1. And this is exactly the point where Photoshop and Affinity and all these applications will cut it. So they have the value of 1. But you see, NUKE can go over 1 without any problem. There is no limit for that at all. And if you then go in here and make the next exposure node, bring it in again. And now we go in and bring here the exposure down again. You see that you haven't lost any details here. And that's the big advantage of working in a 32-bit environment. You never lose data if you do it correctly. There are some problems in some nodes you have to know. For example, if we use a grade node here, which we later learn what this grade node does, you will see that sometimes you have here these clamp ticks. You can clamp black and white, and this then clamps these values to 0 and 1. And yes, you can have negative values, so that's the reason why we can clamp black. You can bring an image first down, 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 so that's nearly black, or on the mathematical idea also in the negative row, and then you can bring it up again. So normally black clamp is okay, but yeah, keep that in mind that for some mathematical operations clamping can be a problem, but in our case not. So that's about the 32-bit here. And at the end of this, I want to talk really briefly about EXRs, because there sometimes is a misconception, which I also see in discussions with developers of 3D software sometime. The discussion is about 32-bit and 16-bit EXRs. So keep in mind that NUKE always works in linear, color, and 32-bit. You bring this into this world, you bring it out with the right node out of this world. But NUKE always thinks like that. But if you are rendering an EXR, you have a little tick box in most of these renderers where you can say, I don't want to output a 32-bit EXR, I want to output a half float image, or sometimes in the renderer it's named a 16-bit EXR. And so many people think now, this is a 16-bit image which I now render out. No. These 16-bit, I can demonstrate it in a write node here from NUKE, and let's make a test.exr to demonstrate that. If you have EXR here, you see data type here. These 16-bit EXRs are removing decimals, so numbers behind the comma. So normally you have 32-bit float values which are much more precise. And if you bring them down to 16-bit half, you have some decimals less, and this means the file size is smaller. And that's the reason why we really often use 16-bit EXRs. But the color range and the thing about this linear and so is all the same. It's only these decimals behind the comma which are cutted. And if you want to know what your EXR has, you can do that with a metadata node. So there's a ViewMetaData Node, and if you hook this up here, you can look into the metadata of the EXR, and that's the big advantage of EXR. We have so many channels, we talked about that in a lesson before, that we can have thousands of channels inside of an EXR, but you also can embed metadata in it. And this is something we use a lot. And if you now look here into the metadata of my product rendering, you, for example, see my camera settings of my 3D camera, the aperture and the f number and so on. And if you look through that here, you see also the compression and how the Cryptomat works. And we have Cryptomat data here. We also see here which V-Ray version I've used to render that out here, and how long my rendering took. Nice, nice, nice. And if we now look here through, yeah, here it is. Here you see it's a 16-bit half float image. So I hope this lesson was useful for you to understand now how you bring your images into NUKE and how to work with this in NUKE. Don't forget that if you write out an image here, you have to decide what color space you want to embed. And please keep in mind that, for example, if you make a JPEG, most of the people on the other side will expect that you output an sRGB. So do it like it is expected. And yeah, I hope now you have enough stuff to think about. We will have the next NUKE practice hour in a while. If you have ideas what you want to see and which topics I should cover, please write me in the comments. Also, if you have problems or questions, you also can write me an email on info@pixeltrain.net if you like that. And if you want to support me, give me a thumbs up, subscribe, maybe think about Patreon me. And yeah, we see each other in the next lesson. Have fun, your Helge Maus.